The PTCT module converts this 0.55 amp signal into a 1.5 volt AC signal for use by the customer interface and analog boards. This signal is filtered on the customer interface board and further filtered and rectified on the analog board before it is split and sent on to the digital board. When the digital board receives these signals, it uses the heavily filtered signal from the multiplexer, MUX, for display and power calculations. The lightly filtered signal is used for short circuit regulation. The microprocessor in PCS compares the output voltage from the PTCT module to the set reference voltage and calculates the difference. PCS then uses this information to generate a pulse width modulated signal for the voltage regulator driver module. The voltage regulator driver module switches the connection between the permanent magnet generator and the main generator field on and off in time with the PWM signal. In this way, the excitation of the generator is controlled to regulate output. The speed load bias signal generated by the PCS is a 3 kHz 12-volt pulse width modulated signal. The duty cycle of the signal ranges from 10 to 90%. This signal can influence the base engine speed from -10% to +10%. If the CM700 does not receive a speed bias signal, it will interpret that as 0% duty cycle and a request for maximum bias to slow. As a result, engine speed will be reduced by 10% to 1350 RPM for a 1500 RPM engine. A 74% duty cycle is interpreted as a null bias request by the CM700. In other words, at 74% duty cycle, the CM700 provides no speed correction from its base speed set point. While this signal is capable of changing the engine speed from -40 to +10% of rated speed, the CM700 limits any change to -10 to +10%. The bus PT signal is used by the PCS as a voltage reference for synchronization. PCS uses the phase detector on the analog board to check this signal against the PTCT module's voltage signal. It then verifies the genset is properly phased to the main bus before allowing the circuit breaker connecting the genset to the bus to close. In automatic mode, the integrated synchronizer in PCS signals the CM700 to vary genset frequency from -10 to +10% of nominal using the speed bias signal. This brings the generator and bus into phase. PCS also matches the genset voltage to the bus, and when the PCS has established synchronization, it sends out the circuit breaker close signal. In manual mode, the PCS still checks for synchronization. If the genset is not synchronized to the bus, it will not allow the breaker to close. Once the genset breaker is closed, the synchronizer is disabled.